Good day, colleagues, and welcome to the ETAP Spark 2024 Global Digital Conference. My name is Alvin Naidu, and I am the Managing Director at Altech. Today, I'm going to be presenting a paper on the Stellenbosch Municipality Control Center utilizing the ETAP SCADA platform. First, I'd like to introduce Altech. Altech is a system integrator of ETAP and an eco-expert for Schneider Electric in sub-Saharan Africa. We are the leaders in electrical SCADA and substation automation. Our core competencies lie in the following areas: substation automation, energy management, power system modeling, smart city design and integration, advanced power system studies, electrical design, MV and LV panel fabrication, and electrical maintenance and testing. Our head office is based in Johannesburg, South Africa. We have branches in Cape Town, an operation in the DRC, and operations in Nigeria. Our focal markets are mining, manufacturing, utilities, facilities, and renewables. Now let's get into the main focus of today and talk about our customer. Well, our customer is Stellenbosch Municipality, which is a municipality based in the Western Cape province of South Africa, servicing more than 200,000 customers. Their digital journey began when they were looking for a capable OEM partner that could provide end-to-end support in establishing a SCADA master station at their control center in order to supervise and operate their distribution network. Furthermore, they envisioned the OEM to make adequate provision in the integration of their multi-source, multi-OEM protection system. Their long-term vision was also for building smart networks that incorporate multiple sources of energy. Well, we'd also like to look at some of the customer challenges before the deployment of the project. They had a legacy SCADA system that was never used, a combination of legacy and new equipment in their network, a multi-OEM protection systems and RTUs in the network, and they were facing increased pressures by Eskom for self-load shedding on their local network. And finally, with the integration and the rise of renewable technologies within distribution networks, SSEG became a fundamental requirement of SCADA. So how did we approach this? Well, we presented to the customer our real-time offering, and based on the success at the neighboring municipality, ETAP was the solution of choice. After listening to the customer and the requirements that they had for their network and where they saw their network going to in the future, we looked at the phased approach for the digital journey, starting that phased approach with baby steps. So fundamentally, when we looked at the approach for the network, we based it on the three pillars of the ETAP SCADA platform. And one of the first pillars of the network is the feature-rich aspect of the system, whereby no other SCADA system in the market has the amount of features that ETAP possesses. And fundamentally, they can use those features in order for the optimization and enhancement of the network. Secondly, the technology. The technology employed is industry standard communication protocols that speak various types of protocols to various types of devices in the network that is vendor agnostic. Furthermore, the technology deployed in terms of cybersecurity, data collection from field devices, data processing within the servers and within the SCADA system is unparalleled. And finally, and most importantly, the future readiness of the system, where no other system has the modular evolutionary approach to optimize and grow as the system grows by adding more and more features into the system. Based on those facts, the customer was absolutely impressed by our comprehensive offering and portfolio, which led us to an order to go ahead with the digitalization of the network. So how did we handle this? Well, we looked at the digital journey and we decided to take the phased approach, breaking it down into 3 phases. Phase 1 is where we build the ETAP models for the network. Number 2, create visibility of the 7 primary substations. Point number 3, integrate a multi-OEM system with both new and legacy technologies. And finally, the development, deployment, and utilization of the digital twin. When we look at phase 2 of the project, which is coming together in the near future, we create visibility on all other primary and secondary substations. We integrate full control functionality, and with full control functionality it's fundamental for your load shedding aspects. Once the integration of control functionality has been introduced, that is the point where we integrate the intelligent load shedding functionality. Which takes us to phase 3, whereby we now introduce distributed energy resource management system, which is fundamental for your microgrid management in the local network, which now takes traditional SCADA to the advanced distribution management system. With advanced distribution management systems comes outage management systems and geospatial integration. Now, to operate this, you need very smart operators, or so we might think. ETAP has a module called Operator Training Simulator that actually trains your operators to the behavioral patterns of your network by setting up simulations and giving them adequate training on the behavioral and the appropriate decisions to make within the network, thus providing the most comprehensive training for control center applications. And inevitably, this creates a robust digital twin with a single source of truth, which is flexible and continuously evolving. So when we look at phase 1, one of the key aspects to phase 1 was the ETAP model development, hardware design, and the SCADA design. So when it came to the ETAP model development, since the network was never modeled, our consulting team had their work cut out for them. But this is not the first time we've been down this road. So we had a procedure in place for undertaking such aspects, where we reviewed all available drawings for the network, be it CAD drawings and be it hand drawings. These were all reviewed. Substation walkthroughs were undertaken in order to verify such drawing, verify components at different areas in the network, and interviewing key stakeholders to understand the behavioral patterns of the network. One of the fundamental and most important tools used during the data collection aspect of the system was the ETAP app, where we could update the model in real time with field device information. Once the models were completed, in order to verify and optimize the network, we conducted a load flow study, short circuit analysis, protection and coordination studies. So, due to the hybrid nature of the network with both new and legacy technologies, it was decided that all new substations or all new-ish type of substations, 61850 communication protocol would be the medium of choice between the IEDs and the RTUs. From the RTUs to the master station, we would use IEC 60870-5-104. At substations where legacy equipment was still in operation, we opted for Modbus RTU and the hardwiring of contacts with the appropriate voltage polarization. Whilst at the R2 level to the master station, we continued to maintain the IEC 104 protocol, thus creating a standardization of 104, speaking from all R2s in the network to the master station. So here are some of the hardware installations that we did at the networks itself. As you can see, our panels were fitted with the local HMIs, the managed network switches, and inside we could see the various terminals for hardwired contacts and the R2s that are in the SCADA panels. Here we can see the local HMI as well fitted into the SCADA panel. Here are some of the pictures of the feeder and the incomer panels that were brought into the network. As can be seen by the various pictures, there are multiple different OEMs that are featured here, which speaks volumes in terms of the vendor agnostic capabilities of the ETAP SCADA system. So going forward, on the SCADA architecture, we chose a simple architecture where at the substation level, all of the R2s had an embedded layer of cybersecurity on them. Speaking to the master station, we chose a common protocol of IEC 104. They then communicated and fed into the network layer that had another layer of cybersecurity on them, which inevitably fed to the primary server and hot standby. We chose the server configuration as a redundancy aspect. Thereafter, we set up your operator stations as well, where we set up 5 fixed operator stations and 10 mobile operator stations. We also configured and engineered multiple mobile monitoring systems for your cell phones. So on the system, we engineered the following views: the ETAP real-time system view, the ETAP SCADA view, the alarm view page, the event view page, the trend view page, finally, the tabular view page. Thereafter, the deployed interfaces were as follows. Directly feeding from the R2s through the master stations were connected the engineering workstations. These were a 2-server setup with a hot standby with full redundancy between them. So should the primary server fail, there'll be a seamless changeover and integration of the hot standby. At the main engineering workstation, model updates could be performed, studies could be undertaken, network modifications, rules and interlocks could also be set up, as well as your mobile switching and your monitoring of the network. We created fixed operator workstations where we could monitor the network, view and acknowledge all alarms, view events, view trends, perform remote switching. We also created your tablet operator workstation, which was 10 mobile operator workstations via iPads and Galaxy tablets in order to monitor the network, view and acknowledge all alarms, view events, view trends, and perform remote switching. We created the mobile view for your mobile smartphones in order to monitor the network, view and acknowledge all alarms, and view events, view trends. So inevitably, what did this create for us with the model development and the SCADA? Well, with the model development, we created a unified model of the entire network where the network now equaled field equipment. And that inevitably drove the SCADA system. So what's in the field equals what's in the design equals what's in the SCADA system, resulting in a completely unified platform. So what did our customer think of this? Well, they were really satisfied with what they received from us in terms of their vision, their expectation matched our deliverables. Our technical support, both from Altech and ETAP, was unparalleled, where we had teams standing by in order to support if there were any problems on the system and if there were any glitches that occurred on the system due to engineering mishaps. System quality was second to none, with the various layers of cybersecurity embedded, as well as the graphics and the smooth and seamless interfaces between the various uh, deployed interfaces. Finally, with the training offered both from ETAP and Altech, the ease of use of the system was seamless. So, how did the system benefit the customer eventually? Well, we created a single source of truth whereby what's in the field equals what's in the design equals what's in the SCADA system. So there's no chance of drawings floating around that's not on the system or stuff installed on the network that doesn't feature in the design. There is a single source of truth within the network itself and a completely seamless, unified platform. From the models that we developed and the studies that we conducted, we managed to sit with the customer and develop operating philosophies for the entire network. These operating philosophies were fundamental for outage management system and network management system, therefore leading to contingency planning for the network. So should outages occur, we have a plan in place in order to speed up the outage and the downtime. These various studies conducted, we managed to optimize protection settings, and with the event playback module, we were able to play back specific events and update settings in terms of the grading philosophy of the network in order to optimize those settings on the network. Finally, with the introduction of all these systems in place, we reduced call-out times by 50%, resulting in shorter outages, resulting in a happier customer, and resulting in 200,000 happier customers to our customer. So how did the success work on a system such as this? Well, the fundamental aspect was working together with the customer in order to drive digitalization in accordance with the customer's vision was fundamental. Creating a unified, robust platform that is a single source of truth, whereby broken down into its simplest format, what's in the design equals what's in the field equals what's in the SCADA system. Seamless transition between each of the three systems. Finally, the development of a future-ready modular system that is always and continuously evolving as customer expectations grow and as customers' needs changes is absolutely fundamental. So therefore, I would like to say thank you to Stellenbosch Municipality for affording us the opportunity to drive digitalization in their electrical network, as well as affording us the opportunity to showcase their ETAP experience with the world. Most importantly, I'd also like to thank ETAP for the unconditional support, training to deploy projects of this nature that disrupt the industry, and the opportunity to present this project at the 2024 Spark conference. Thank you.